Hello everyone and welcome to today's session, The Future of Mobile and Stationary Road Weather Data. My name is Ella Joseph and I will be your host today. Before we start, I would like to mention a few organizational points. This webinar is recorded and you will receive a link to the recording per email tomorrow. You are all in listen-only mode, but this should not stop you from asking your questions. You can do it by writing your questions in the question tab. Our today's presenters are Stephen Marks, who is an RWS manager at Odd Hydromet, and Peter Rau from Informatik Werkstatt, who is our partner for the last 20 years and will demonstrate the ViewMondo software for us. Okay, without further ado, I wish you all a great and informative time. Stephen, over to you.
Thank you very much, Ella. Thanks for the introduction, and good morning, good afternoon, good evening, or good night, depending on where you are. Today is the 5th, May the 5th, and up to now, I was planning to visit some of your customers and some of you and meet you at the exhibition, for example, 2 weeks ago in Amsterdam at the Intertraffic, but unfortunately, we are facing rough times, all of us, the whole world globally. So I'm even more happier than that our marketing department today has managed to set up this webinar so we can reach out to you, shake your hands virtually, and show you what kind of solutions we are offering you, what we can give you onto your hand, and also go with you the path in the future. And this is something which I would like to show you today. Let's go on to the agenda. First of all, I will show you who we are, give you an insight of the company, Odd Hydromet. Then I would let you know what our challenges are, what the pain is, where we want to go with you in the future, and then also our solutions and a best practice example. Let's start off with the Odd Hydromet group, which is a group which is divided up, first of all, as you can maybe see in the name. Hydromet is the hydrology and also meteorology. Under the hydrology, we have independent companies, entities with a long tradition, actually, and they are divided up in these two big groups, hydrology and meteorology. We are going to look at a bit more on the meteorology side today, and here especially to the column Luft, where I'm working for. The meteorology is divided up in first of all meteorology and climatology. These are the experts who are looking at our climate and our weather. They need high precise measurement systems which we provide. Renewable energy is something which has come up the last couple of years and is a very, very important column for us, and very important because here we are managing sensors for the solar energy and also the wind parks. And this is something where we have, in Germany at least, broke a record 2 weeks ago where it was very sunny and very windy. We had over 60 gigawatts per hour. And that was produced only by renewable energy, which is a record for the German industry. On the right, you've got agricultural meteorology, very interesting as well. The importance is growing because of the weather extremes we are facing. Here, this is for farmers and wine growers to find out how to manage their water system. And in the near middle on the right, we've got the road and runway weather. This is what we are talking about today. Here we see this as a keyword for all solutions with to increase the safety of cars, trains, and aeroplanes. The last word to the Odd Hydro group, the Hydromet group. We are facing, we have got offices in 18 different countries all around the world, and we have got in further 90 countries we are representing our technology with partners and distributors. Important to say is that we are not working on a short term at the moment in Germany, in Fellbach. Our production is running like it's always been running. We've had some nice big orders coming from different countries, some tenders, and also the German Weather Service. So we're in a very fortunate situation that we, at the moment, the production is highly running, and we're very confident and very happy that we've got this situation at the moment. And we hope, of course, it will continue like that over the year. So let's have a quick look into the past. This is how the road weather and the maintenance looked like a few years ago, 139 years. That is the age of our company with a long tradition, and this is how probably it looked like. In the meantime, many things have changed. We haven't got so much staff. It's not so cost effective anymore, and the winter maintenance or the road maintenance is developed with a lot of sensors and also more predictable than it was in the past. But still, we are facing many unpredictabilities, and that's also because of the extreme weather and the urban climate and the microclimate we are facing at the moment. So our challenges for the future are strong winds, which cause to stop opening highways. We are facing floods. Also, that's something which has come up the last few years only, that the tarmac is changing due to the solar radiation. And also, of course, snow. We here in Middle Europe, we've experienced a very mild winter, but it's just a year ago where we had a chaotic winter, and this is something we often forget. And this is also something which explains the weather situation, that also 1 year ago we had such strong snowfall that for many days the roads were blocked, and it took a long time to clear that. If we break that down on a city, this is a city in South Germany, in Bavaria, where we have got several different situations. We have got a city with 2 rivers running past it, and an altitude difference of 120 meters. So what the people in the city, the authorities are telling us is that it can be that in the city center you would have a dry road, but on the outside of the city center, the roads which are near to the river, they could be wet or even icy at the same time. Just as like the high parts of the cities, it could be minus degrees there, and in the low parts of the city, we could have double-digit plus degrees. And additionally to that, we have got the urban climate, which is a mankind caused weather situation. Like in this city, we have a paper factory which releases water vapor into the air through a chimney. So they are telling us it can snow there around that factory, where a few kilometers away the roads are dry. So this is something we really have to take in consideration, and this is something where we need a better picture and a better view of what's happening in my surrounding. To give you an even better overview of how this can work out, and that only to look at one measurement is not enough. This is a nice example. Here we have got 3 different streets which have got all the same surface temperature, which is minus 0.7. Now, as you can see optically, these 3 streets all look different, but if you only rely on one part of measurement, you will take the wrong action. So let's look at the left street first. The left street is, as you can see, minus 0.7 Celsius. But here the snow has stopped. The air temperature is at 1.5 degrees positive. The sky is clearing up. And we've got a friction, measured friction of 0.71. So this is quite high actually. The max is, I think, 0.82. So here the friction is high, the water film is very low, and the sky is clearing up. So we can keep an eye on it, but we don't have to treat this road. It's a different situation we have here. This road has to be treated because the friction is very low, it's very slippery, and the air temperature is minus 2,2. So here definitely we have to take action. The last example, if you only have a quick look, it show you that here everything is fine, but we still see that the air temperature is minus 5,3, but the friction is very high and the water film is low. So here we don't have to treat anything, and this gives you a nice example of how important it is to get different parameters to get a better picture of your situation, of your city, of your roads, of your highways, and this will give you a better view of how to take action, which action to take. So the future will be to build up a network of different sensors, a mixture between mobile and stationary sensors, just like you can see here. The more the better, of course, give you a better picture. Weather conditions, as I said, can vary across short distances. Try to prioritize the risky parts, like the cold spots or big crossings of road crossings, higher elevations, bridges, and consider also a mix of fixed mobile sensors and stationary mobile stationary sensors. And this is something I'm going to show you in the next slide. We have got invasive sensors which you build into the tarmac. They are flush mounted into the tarmac, and the good thing about these ones is it's a two house design. That means the housing, the black part around it, is the housing, and the electronic is the white part in the middle. So this will give you the opportunity to, although the sensor is built into the street, to release the sensor for calibration purposes or maintenance purposes. And that is a big benefit, which also we had a question in the previous webinar about if you renew the tarmac, for example, what happens to the sensor? And the answer would be that if you renew the tarmac, you actually just have to also just demount the sensor, and you could leave the frame in the street. A next benefit for here is you got two depth temperatures you can let into the street, and that will avoid having black ice, for example. They are 5 centimeters or 30 centimeters deep, and that will give you a better overview of the tendons and how the temperature is developing. The nice thing about this sensor is it gives you the freezing temperature for 3 different gritting materials. That's natrium, magnesium, and calcium chloride, and can also show the water film height up to 4 millimeters. If you fancy an active sensor, we have got this ARS sensor. It's called ARS 31, and it's built just the same like the IRS, also a 2-part housing design, but this one, it heats up and cools down, so it measures the freezing point, and that up to, or down to actually, minus 40 degrees. The good thing about this sensor is it's independent on the gritting mixture. So if you combine it with the IRS, you get a good picture. And this is also often the specification of some road authorities, to have a mix of this sensor with the IRS. And especially for runways where we don't put out salt onto the runway, this sensor is the right one to build into the tarmac. Often you have solutions where you can't build in an invasive sensor. Then we have a non-invasive sensor, which you can hang up to 6 or 15 meters above the street. And this will give you also the surface condition, the temperature, the friction, and the ice depth, for example, from the bridge. A nice picture will show you here. where we have got it mounted on different altitudes. On the left, you will have a very high altitude. On the right, on the post, a little bit lower. So this works perfectly also in combination in this picture on the bottom right with a camera and a weather station. Sorry, go one back. To complete our mobile sensors, or our sensors, we've got the mobile sensor. And this, by the fact that this sensor can be used for control trips and create route profiles, this measures values which can also be transferred directly to the control center with the software Viewmondo, which we will hear just now more about it. And the operation manager can then decide if he has to send our people to do the maintenance or not. Our customers are telling us that because they are using this mobile sensor, they are saving up to 20% of their costs. And also, we have got customers who use the sensor for documentation purposes. So if you have a service provider who does the maintenance, for example, he can then prove that he's serviced different parts of the cities by having this sensor in combination with the software. The stationary brother of the mobile Marvis is the so-called Starvis. This is a sensor which is easily can be mounted up to onto posts 5 to 6 meters and is very flexible with integrating. And to complete the sensors, we have got weather stations which should always be in combination with the ice detection solutions. These sensors will give you the air pressure and the wind speed, the precipitation, for example, and also the wind direction. So this is something where we saw on the picture before we could install on highways and to also find out if how the traffic can be controlled, for example. And we've got these sensors, for example, in along high-speed train railway lines to find out if the train can take that same speed which is planned, or if it should reduce the speed. Our customer in South Germany, in Geislingen, he has adopted all these ideas, and he's got an invasive sensor in the street, a IRS 31, in combination with the, as you can see on the picture here, NIRS 31, which is a non-invasive sensor, and he's got a compact weather station, the WS 400, which gives him a good overview of what's happening in his city. Because this city also has got rivers and is it's at a climb, so many cars go through the city, and the altitude difference is also quite large. The extremes in this city are also there, and through these sensors, he's got a good overview and a good picture in combination with the Viewmondo software, which saves a lot of costs for this city and gives him a good overview of what's happening, and so he can measure out the winter maintenance. I hope I was able to give you a good idea of how important it is at the moment already to get a good picture of what's happening, and also what it will mean for the future. What it means that it will be even more important to have a good picture of what's happening in your city and in your environment. I'm going to pass on back to Ela Joseph, who's going to moderate the webinar, and thank you first of all for your interest. Ela.
Thank you very much, Stephen, for this presentation. In this moment, I would like to remind you about the question tab on your control panel. I see that you're writing down your questions already, but if there is still something unclear or you're curious about, Just please use it. We will do our best to answer all of these questions at the end of the presentation. If we do not manage, we will still follow up on them after the session. And now, Peter, over to you.
Thank you, Ayla. Welcome, everybody. I'd like to introduce, as announced, our software Viewmondo that we use to collect, display, distribute, and process the data from both mobile and stationary sensors. Quickly to our company, we've been founded in 1998. We are partnered with Luft Software Solutions since 2001, and we've been providing solutions like SmartView, SmartGraph, Elcom, and the iOS and CloudGate Marvis app. You might have seen some of that. So to the software. Viewmondo is a web-based application. The complete user interface is HTML5 with JavaScript, so there are no plugins needed. It works with all the modern browsers. The complete administration interface is integrated. It's multilingual, so and multi-time zone based. We have a user role-based access rights model, and the software is available as a software as a service in hosting or as a licensed software for in-house installation. So how is data captured? How is it displayed? How is it distributed? And how is it processed in Viewmondo? Captured, we do provide various protocols to collect the data from the sensors. First of all, the protocol for the Marvis apps, which allows the online transfer, near-time, online, real-time of the Marvis data and camera images from the tablet, the smartphone, or the CloudGate, or Matrix Router, which is a special application from Canada. We do support NTC/IP protocol for the United States, mainly, and some other parts of the planet. We, of course, support the UMB protocol to directly connect to the UMB sensors. We do support the German TLS over IP protocol. We support the MSSI protocol, which is provided by the Elcom. And we can grab camera images from an HTTP camera and from NTC/IP snapshot cameras. And we can also import data at the moment through CSV files. If needed, we can extend that to other formats. The best way to look at data is to look at data. So the rather small city, actually, Geislingen, that Stephen mentioned before, we see their live data here at the moment. You can see the two stationary sensors. One is the non-invasive sensor with a weather with the WS400. The other one is the invasive sensor, and they have one Marvis, which is parked. It's not been used in a while. You can see last used in February. That's why the actual measure value you see here is darker and grayed out. It's not up to date. One feature we have here, of course, you see your stations, if you have multiple stations in a group display on a map. If you have really many stations, you can have a hierarchical group of stations, and you will get that view for all of your groups. We have one thing we can do is we can analyze the data for critical spots or cold spots. Unfortunately, last season there have not been many, so you can't really see that many in the city, but you can see there is actually critical spots in the city, which might be a good place to mount a stationary value. To look at the data, we have display for the current data, which we need to decide whether immediate action is needed or not. We have the camera picture, which goes with the data. You can, of course, navigate forth and back in the data, including the camera picture here. You see the data in gauges, you see it in tables. We can also view forecast data. This is provided by the Norwegian Meteorological Service. They actually provide data for a lot of cities, localized data on the planet. And we have the diagrams and the hourly forecast here. So this is where we decide on immediate actions. You might want to look back what's been happening. That's why we provide a diagram view, which also has the data in tables, of course. You can export your data here directly from the website in CSV format to process the data in, for example, in Excel. We have, for the MAVIS, the data displayed on a map, of course, because the sensor is moving. It makes most sense to view the data on a map. Here you can see data from the last measurement drive. You can select the actual sensor you want to see on the map. For example, friction is good here, is bad here. The spots you might want to watch and go for icing, for de-icing. You can use the measurement drive, for example, and that's just an example of combining your stationary and your mobile data. You can use the measurement drive to process that against your stationary data to have some indication about whether your sensor is in good shape. Here you see the software takes the measure values around the stationary sensor for the same time, of course, and compares. Here we have for the stationary sensor the time and the time range from the mobile sensor. We have 11 measure values, and you see it's a pretty good match. You will rarely get exactly the same results, of course, because the stationary sensor is one spot and the MAVIS is measuring around that. So you might pick up, like we have here, a water patch with the mobile sensor that you don't have. Or you have in this case, you actually have a water patch right on the stationary sensor, which the MAVIS did not pick up. Then you will have differences here. So after collecting the data, we can distribute the data for post-processing. We can do that in an automatic process in the background, exporting the data and FTP that to your server if you need it. In CSV or XML format, we also provide the WMO buffer format, which is required by some of the forecasting services like the German weather service. And you can access your data online as well using a web API in JSON or XML format. And we do some data processing in the software. You can configure alarms depending on thresholds, and whenever the sensor value exceeds a threshold or is below a threshold, you will get a notification by email. We do have a quality check, plausibility check module, which is based on rules. It allows basic range checking. It allows for checking if measure values are constant for a too long time, which might indicate the sensor is broken. Same applies for if the measure value the difference in measure values is too high. If the temperature is jumping, something is wrong with the temperature sensor. But we can also cross-check data from different parameters like precipitation type, rain, at low temperatures is not plausible, or the road condition dry and the water film above 0 is not plausible. We do have a recommendation for gritting. I can show that with data from a real sensor. And we also have a rather simple prognosis for the road temperature and the road condition. This is based on a model that was developed in Canada a few years ago, and we have ported that here. The gritting recommendation picks up the local data, and since I know there has been a spot, as I mentioned before, we didn't have many, not a lot snow last season, but here we had in the morning, it was snowing. You see there's a gritting recommendation of 30 grams of wet salt. You can also see in the camera picture that there was some contamination on the road, and sometime later we have you can see that the gritting had been done, and its road conditions, chemical damp, a very small amount of liquid on the road, and no ice, so we don't need to add more salt to the road. That's one of the modules we have. We also have what I've been showing before, the cross-checking of the stationary and mobile measure values for proactive maintenance. And we have a very specific module for runway condition code calculation for runways on airports. But that's the topic of a separate presentation. So any questions? Thank you very much. Back to Ela.
Thank you very much, Peter, for your presentation. There have been a few questions coming already. If you still want to ask any questions, please write it down. We have a few minutes to go. I will start with the first one. This one is for you, Stephen. You've been introducing or showing us the IRS sensor that can be installed on the highway road, and there is a question about extreme conditions. Could it be installed in a road in a cold Nur-Sultan city in the North Kazakhstan, Silk Road Highway, for example?
Yes, that's a very interesting question. Physically, it can be installed there, but I know from Manuel Kreißig, who's also in the call, he is our specialist if it comes to a hotline and technician trainings, that there are some challenges if it comes to parts where the snow gets dirty after a while. I know from non-invasive sensors that if they are looking down onto the snow, that if the snow color changes from originally white to maybe a black, that non-invasive sensor won't detect the snow so well. So I also think that the IRS, which is, as we know, embedded in the tarmac, that should be actually able to be built into a very cold area. What do you say, Manuel? You've got experience. You've been to that part of the countries.
Hello, also from my side. First of all, of course, yes, thank you for the question. I would say that, yeah, of course, you can use the IRS 31 Pro also in very cold, yeah, places. Why not? You have to know that, of course, the measurements are limited here, because if there is a lot of snow on the road, then of course the sensor will not be able to measure anymore for example, the snow height, because the sensor has a limitation of 4 millimeters or up to 4 millimeters for the measurement of the water film and the snow height. So this can be maybe a problem if it's snowing too much. But anyway, the sensor will be able to give you other parameters like the road temperature, of course, and also the ground temperatures. No problem for that.
All right, so let's jump to another one. This one is also for Stephen. Is there any recommendation for the distance between the different stations if we have a 400-kilometer long highway? And this is for SA, and the parameters required are mainly rain, visibility, water film, and temperature sensors.
Yes, I reckon KSA is Saudi Arabia, and 400 kilometers is of course a long distance, and my answer would be, of course, as many as possible. But if, of course, if you have, for example, only 10 kilometers difference, that is okay. If you only have 1 kilometer difference, I don't think you will have different values if it comes to a long highway like that. So as recommendation, I would say as many as possible, and to put up to detect the visibility, we have got visibility sensors, and also the water film height and temperature, and that should be done with a invasive sensor, of course. As Manuel has just said, it can detect up to 4 millimeters, and this is something which is ideal for these kinds of highways.
Okay, we've been talking a lot about snow, and do we have any example of application for tropical country without snow?
Yes, we have. Our weather stations are able to detect any other kinds of weather parameters, just as temperature, also the rain, then also the wind direction, the wind strength. So these are examples where we've got nothing to do with snow. Visibility, for example, is also an important parameter which can give you a good overview of what's happening, especially in countries where, for example, we have sandstorms. When we have sandstorms, we can detect this with a visibility sensor, and this is something which is getting more important in those countries.
All right, the next one is for Peter. On which data is the road prognosis based on?
Pardon?
On which data is the road prognosis based on?
Oh, okay, the road temperature prognosis. It's based on the data from the local sensors. We need road temperature, a depth sensor. It's also taking into the processing the road condition, and I think I would have to look up. We have different parameters that go in. Also the freezing temperature. It does calculate. It has a model where you can configure the surface, what the surface is made up. Is it concrete or is it a bridge? Depending on that, the temperature is calculated, or the temperature difference. Also, the sun exposure of the area. So it takes those parameters into account. I hope I could cover that. It's rather specific, so.
Okay, thank you. If this was not the answer you've been expecting, then please let us know and we'll follow up after the webinar. Now, another question. Stephen, you've been presenting compact weather stations from Luft. Maybe Manuel can help with that one. How does the WS series detect lightning strikes?
Yes, that's something I think, Manuel, you know more about that.
Only the WS800 has the possibility to detect lightning events. That means what we do is to detect the discharge, electromagnetic discharge in the air, and there is a small chip inside the WS800 which will be able to detect this in a, let's say, diameter of max 20 kilometers, and so you will get an information about the events. And the sensor will sum up these events, so you will get an information 2 or 3, and that means in this time you had 3 of these discharges, and that's it. What the sensor can do.
Okay. I will go to a question about the best practices. Do you have best practices for deploying both fixed and mobile sensors to improve the spatial and temporal resolutions of mobile and fixed sensors, respectively?
Yes, we have got best practice for, I understand the question that best practice for stationary and mobile. Was that the question?
Yes,
Yeah,
yes.
Just okay. Yes, we have. We've got some of them, for example, in Geislingen, that is mobile and fixed, but also other cities, and we've got some of these. So the person who gave us the question, I'm very happy to send him a link with some of our best practices in that regard, mobile and stationary.
Mm-hmm. Another one is for you, Peter. Is the forecasting service subscription-based or included in the software?
The forecast from the Norwegian meteorological service is for free, and we include that for free in our software.
Perfect. Okay, so another one for you, Peter. Which other sensors can be integrated into software system?
The Viewmonitor software is not really restricted in terms of what kinds of data we can show or what kind of sensor values we can show. We do support the whole range of sensors, and if needed, we can easily add other measure parameters if there are specific parameters you want to see.
All right. This one for you, Stephen and Manuel. Most of the sensors use UMB protocols, but the compact weather stations support Modbus. Will Luft provide other sensors with Modbus protocol later on?
Yeah, normally we, of course, have implemented the Modbus protocol in the WS sensor family because the WS sensor family goes in a lot of different applications where also normally Modbus can be one of the protocols used. If we talk about road weather stations, the Modbus is not very important here. So that's the reason why normally the special, let's say, road weather sensors have not Modbus implemented. That's the reason, and so it's not a need until now. So all the sensors which now which can be used in applications where also Modbus is used, of course, normally have this Modbus protocol inside.
All right. And now there is a question regarding Marvis, which we've seen in Stephen's presentation shortly. For a Marvis system, is there a delay from the startup to when the sensor can actually start reporting value? For example, when you start your vehicle and start driving, are values available right away or not?
Well, first of all, you have to like calibrate the Marvis sensor, but that's only a one-time action. That's only at the beginning, takes a few seconds, and then from then on you can measure the street up to, I think it is 100 measurements per second. So if you drive 80 kilometers an hour, it's every 20 centimeters. So that is something which you don't have to wait for so as soon as you start.
Okay, there is a question about the country of origin. Do we have any production sites outside of Germany?
No, we have production sites in Germany, in Fellbach, near Stuttgart.
Okay, I see that we are running out of time, so maybe I ask the last question from many that came to us. Thank you very much for that. Peter, in which ways can the data be exported? Any standard export formats for state agencies like weather services that want to see road weather data in a special format?
Well, we do provide, which is requested by the German weather service, the WMO buffer format, which is quite specific and special. Other than that, I don't know of any specific format. We do export data to other providers, usually in text CSV format, or we have customers that actually use our JSON-based API to access the data. If we need anything specific, there's always a way to implement that. Just talk to us.
Okay, great. So we are running out of time. Thank you very much for all the questions. I'm aware we were not able to answer all of them in that session, but we will do our best to follow up on them after this webinar. Please don't hesitate to contact us if you have any additional questions. Thank you for your time. Thank you to our presenters for a great session. And I wish you a great day, and I hope to hear from you soon. Goodbye.